All right. So thanks for coming to this session. My name is Keith Basil. With me is my esteemed colleague, Shawn Wells. And we're going to talk about compliance, speed, and agility with OpenStack. So with that, we will get started here. So just a real quick agenda. We're going to discuss and show why compliance is complex. We're going to give you an idea of our approach, who's involved with the project that we're demoing, and show a cool demo that should work out.
Live demo.
Live demo. We're testing the waters here.
It's compiling in the background right now, actually.
And this fan is running on this computer, so it's some heavy stuff going on. Anyway, so a little bit about me. I work at Red Hat. It's pretty much the only thing you need to know, I guess. I was co-author with this guy on the, and many others, by the way, on the OpenStack security guide. We help coordinate some of that work there. And Shawn, you want to?
Yeah, I work at Red Hat. Been here 10 years, so former NSA. A lot of my focus is around automating security. So the idea is compliance can scale security when we automate it. So how do we start bringing that automation into the OS and OpenStack and middleware and everything else?
Cool. We mentioned the security guide. It was a great effort. The community needed that. Unfortunately, it was very generic. It wasn't real specific in terms of how to make your system more secure, but we wanted to kind of preset the stage here by mentioning that it was a great project, but we need to do more, and this talk is about the more part. So upstream, there's this community called OpenControl. You can see on the screen who the members are, Pivotal Amazon via 18F. 18F is a contractor in the DC Metro at the address of 18th Street and F. This is where the name comes from. Mm-hmm. And then you see Red Hat Public Sector, which Shawn is a part of, that's involved as well. And then we're trying to recruit other people to get into this once you see what we're trying to do. Anything you want to add to that?
No, it's an open source movement, so we'll get into all the specifics. I think it'll be fun.
Cool. Okay, so what is the problem? Let's jump right into it. So why is compliance complex? So everything is faster. Open source is faster. There's a lot of innovation going upstream. Agile, cloud, DevOps. Everybody knows those keywords and buzzwords, so you don't have to repeat that for the folks in the room. But on the compliance side, we're in the dark ages, right? Everything's struggling to keep up. The cycle is too fast for traditional or classical compliance responses. So there are many frameworks that we have to adhere to or be aware of, and many controls. So this is a smattering of compliance frameworks worldwide that Red Hat is tracking. So you can see DISA for the intelligence community and DoD, FedRAMP, NIST, the Cloud Security Alliance is very involved. Mike Purcell, who's in the audience here, is from our CTO office. He's been very involved in writing some of the specs for ETSI, which is giving a framework for the NFV telco space, which is great. Classical ones such as HIPAA. You've got the French government behind ANSSI on the left with the big circle. So we have to be aware of those things from a security point of view, because when we go to deploy OpenStack in a particular region, we might be beholden to one of these frameworks. So it has to be on our radar. There's a lot of frameworks. And then within those frameworks, there are a lot of controls. So this slide here represents a matrix of the control groups as defined by the Cloud Security Alliance. So you've got application interface security as one control group, and there's several things that you need to be aware of inside that control group. So if you have a stack of frameworks, stack of controls, you have to make that work within OpenStack. So this is a big contributor to the compliance overall. And then you have to look at the entire stack based on the level of compliance. So Shawn and I have experience with FedRAMP in the US public sector. And depending on the security level that you're trying to attain with FedRAMP, there could be low, there could be moderate, and there could be high. So for a low situation, you might only look at the first 4 layers of your infrastructure stack, right? But if you go to something like FedRAMP High, you're going to be attesting that the hardware has not been tampered with, and you have to go down even further. So the depth of the layer adds to the complexity as well. So this is a synopsis of what we're dealing with. So if you define on the left there your infrastructure being OpenStack, or anything that you're going to run on top of OpenStack as infra, then you have to create these compliance artifacts. You have to create a system security plan. You have to do a gap analysis report. You have to have audit and remediation baselines in terms of documentation. And you have to make sure all of that applies to whatever framework that you're adhering to. And then that's version 1, and then you repeat and rinse and go over and over again. So the problem is this cycle, and we'll give a more specific example of this with FedRAMP. So if we zoom into FedRAMP, FedRAMP is a framework for cloud service providers offering services to the US public sector, just as a context. They have this thing called FedRAMP Accelerated, which is the fastest way you can get what's called an ATO. An ATO is an authority to operate within FedRAMP. So with a FedRAMP Accelerated, best case scenario is probably 5 to 6 months, okay, before you get a stamp of approval to operate and deploy your cloud. So as we know from OpenStack being here in Australia, that's too late for us. By the time you've certified an OpenStack platform system, you're already one version behind because the new release is out by the time you get your stamp of approval. So this is what it looks like. So if you had a Queens release, you go through the process, you get all your docs together, you submit that to what's called the Joint Authorization Board, the JAB. They look at everything, check the box, yes, this is good, looks good. They give you what's called a provisional ATO, the PATO, and under 6 months, that's 2,600 man hours to create all that work and have the submission. Okay, that's ridiculously slow based on everything you saw before in terms of DevOps, agility, et cetera. So by the time you go through that process, you're already one release behind. So we're always lagging in this case, and this is the essence of the problem that we're trying to solve for in this model. So compliance as code is the way we're trying to solve this, right? Everything else is code driven, everything else is DevOps driven, so why not compliance? And when you think about it, it really kind of makes sense to us, and this is what we're going to talk about in a little bit more detail. So this slide here represents the integration of Agile security into your current process, right? So we're adding things like, as security, I want to log this, as security, I need to do this. So we want to have this integration of the security awareness, the compliance awareness into an existing DevOps and continuous integration process. So this is the idea in a nutshell, right? So that when we deploy our code, we have awareness and vetting or continuous integration checks, right, already built into our process so that we get that agility out of the box. So what we've done in Red Hat is try to create a flow to work with that particular model. So there's some Red Hat folks here. I'll give a shout out to Garth from the product security side, where we have modified BUGZILLA. So when a feature comes in that's security related, when a bug comes in that's security related or remediation to make the system harder, we can now triage that based on low, moderate, or high levels of security, and then further triage that by a control group. So, for example, if something comes in that's related to SE Linux, it may be high, may be related to a container breakout that we're trying to prevent, so we'll mark that as high, and then we'll also put that in infrastructure and virtualization security as a control group. That allows us to track it through the entire development process and to link to compliance schemas as part of the software of the build system so that we can actually now crank out some really cool artifacts related to the exact thing that we're going to release for that system. So this is a high level, and we'll give a copy of this talk later. So this is some of the examples of what we've done internally with BUGZILLA. But let me go back because this development swim lane here, it could be anything. I mean, it doesn't have to be tied to BUGZILLA, but if you're using something like Trello or Pivotal to track your Agile thing, you could just create some kind of artifact inside your development process to track the compliance, to put that baked in. So this is what we're doing for BUGZILLA. You can see moderate and the infrastructure invert, all the levels. And then we can also, we're working with some governments or government compliance agencies in terms of their frameworks where they don't want what they're suggesting to be public. So we can actually mark that as sensitive. So it will be in the BUGZILLA system. All of our security engineers can see it. They can work on it and fix it, but the public can't see what we're doing to make the system harder, right? To expose those attack vectors to bad actors. So, and I'll finish here talking about the Red Hat specific, but we have a tool called Director, which actually deploys OpenStack. So the idea here is to roll up all of those security feature development artifacts and to deliver them as part of the product where everything that's a low classification that does not impact OpenStack services by default, we're going to include in the product by default, okay? So hardened images, docs, OpenSCAP profiles, we're going to ship those. But anything that could detrimentally impact a default OpenStack system, we want to classify as either moderate or high, because when you turn those things on, services will break, okay? And that's okay, because with the more you do the slider for more security, then you expect more stringent controls around those services. So this is where a deployer would go in and says, I want to do a FedRAMP high system based on OpenStack. I would do -- environment high, and then all of the configurations and recommendations for that would go into play, and you'd have a high system out of the box. We would also like to ship an OpenSCAP profile that represents high, so you can trust but verify your deployment once it's done. So this is the philosophical thinking that we have on the OpenStack platform team in Red Hat. So compliance as code, one of the coolest features of this is that we can do what's called inheritance. So for example, if you build a complete stack, remember compliance is a full stack exercise, right? So now we can pull in any of the compliance as code work for the hardware attestation. We can now pull in the operating system specific work. We can pull in the platform as a service layer, and then anything that's non-technical, like how you handle personnel security, right? So as a technical company, we don't dictate how you do personnel security. In some cases, like in DISA, you have armed guards with machine guns sitting outside the data center, right? That has nothing to do with Red Hat, but it should be in your overall system security plan when it comes to submitting those artifacts for audit and remediation and just the whole repeat of that. So what's cool about this, if the code is done in layers, we can then just pull in what we need to kind of on-demand build a SSP, a system security plan, or any of the artifacts that we need. So this is a beautiful thing for us, and it allows us to continue to be fast. And from the Red Hat side, when we deliver something with what we call a Z-stream release, it's like a point release. So let's say Red Hat OpenStack Platform version 10 would have a set of documents that would be delivered. And then when we do a point release, you'll have update. We'll just run the tooling again and have a fresh update and gather up everything that we have there. So that's the idea, and we're slowly getting there. And this is kind of the vision that we have for this in terms of OpenStack. So I'm going to hand it over to Shawn, and you're up.
Cool. So let's get some context and show some code. So the idea is, as we go through some kind of security process, we generally categorize the system. Why don't we say government will do secret and top secret, or PCI and HIPAA, or something like this. And depending on that classification, you'll assign some security controls. So if it's an unclassified personal blog, you may not really care. But if it's something that a government's using, you want certified crypto, you want 30-character passwords, all these other configuration checks. And then you have to implement them. So if I have a high-level guidance that says secure communications, well, what does that mean at the operating system and the middleware and OpenStack and all the other routers that may be in your environment? You have to translate do secure communications to every component in your information system. And then you have to assess it. Like, how do you stay in compliance over time? When a third-party auditor comes in, you have to kind of tell them what to check. So wouldn't it be nice if we just focused on select, implement, and assess or evaluate? And for that first one, we want to, and we are actually, factually we are, working with different standards bodies like PCI, the US government, the French government for ANSSI standards, and we're actually using that relationship to authoritatively identify what security controls apply to OpenStack at a secret level, a top secret, a healthcare. We're kind of making these profiles. And then from there, we're writing specific implementation that translates that high-level prose into something that's actually like a configuration setting. And then we're also writing automation. SCAP is a language security automation protocol that will give you like a pass or fail. You have chef and spec. So we're writing out these evaluation baselines as well. So now when we go into, say, the US government, and they say this is going to be OpenStack for the military, we can translate, here are all the controls you need to worry about for OpenStack, Linux, and middleware. Here's the nerd knobs that you change in your configuration files. And then here's a body of automation to give you a pass or fail report. So when your third-party auditors can come in, they just get a red light, green light Christmas tree of compliance. So all of that is what we're developing. We need somewhere to house this. So the US government has what they call the National Checklist Program. Other governments are catching up. Australia through the Defense Signals Directorate, or whatever they call themselves now. They're developing something similar. And the idea is we want to have a repository from a neutral party. So in the US, it's our National Institute of Science and Technology, Standards and Technology. And we create these checklists, like I'm running OpenStack for intelligence, I'm running OpenStack for healthcare, and it provides all of that low-level guidance. So that's really nice that you can go to a .gov webpage and pull it down, but we have to develop this content somewhere. And for that purpose, we've joined an open source project that has Pivotal, the US government, system integrators like Accenture, Deloitte, BUGZILLA, Red Hat, and others. So why don't we actually take a look and see how this whole pixie dust and wizardry works. Is that kind of interesting? Cool. Before I jump that, well, actually, let me jump in, make sure my compile doesn't have any errors. It didn't. So let's orientate ourselves just a little bit. So in the US government, and I believe most other people, they have to develop system security plans, which are like these really big Word documents about what security controls you're doing. Or it's a spreadsheet from hell, where like the first column is some security requirement, tertiary columns are how you meet it, and next thing you know, you have these huge Word documents.
And if you saw the slide earlier where it says 2,600 man hours to do that, this is what we're talking about, where you have to grab the SSP from the FedRAMP site, you have to go through all the controls, you have to assess your system, you fill in the blank, it's a lot of typey, and not only the typey, but you have to have a security guy or person that's an expert that understands how that control translates into like a technical implementation. So it's very heavy process.
So let's take a look, right? So we keep mentioning high being, why don't we just call it top secret, and low being, I don't know, random blogs or something. So if we take a look at some of their templates, this is one of them. And I'll make it a bit bigger here. So the first thing is it's about 400 pages long. And I know it's a little, I guess up there it's actually quite large, but it's about 400 pages. So if we scroll down maybe arbitrarily, as soon as the buffer catches up, still trying to catch up. Still trying.
This is actually part of the demo.
Yeah, so it's 400 pages. It takes a while. So now you have all these controls. Like in this case, you have to hire a third party to do penetration testing or something. So I go in and I say, whose responsible role is that?
Basil.
Yeah, blame Keith Basil. And I'm done typing, but the buffer is still just catching up here. Yeah, so you talk if it's implemented, you check if it's organizational control or something you've outsourced to like your cloud provider. So why don't we say it's configured by us as a customer. And you have to write some pros, like I hired a third party called Fubar, and you write some pros. So as we go on, there's 400 pages of this. And there's 400 pages per information system component. So your networking tier, why don't we say Cisco, your operating system, Red Hat, Ubuntu, CentOS, your OpenStack, your middleware server, your app, and you can see next thing you know, you're generating literally thousands of pages of documentation. So wouldn't it be nice, and this is only the documentation, what happens when I want to actually evaluate a control for a red light, green light? So enter two open source projects. The first, and these are all, believe it or not, they're public domain projects. So the first is something called SCAP Security Guide. And going through the code isn't so important. But the premise is we wanted to get a community together to translate the high-level pros of like, do secure communications. And we wanted to translate that to different technologies. So a translation for Debian, for JBoss, for Firefox, Fedora, OpenSUSE, Red Hat Linux, Ubuntu, so forth. And now I have content that'll give me a red light, green light, pass or fail. So when I actually take a look at that, this is, one second. This is the US government baseline for Linux. And I can go through, and I'm just skipping around. But out of the box, a default OpenStack installation, at least the Red Hat side, it's only like 60% compliant out of the box. So we're failing a whole bunch of those nerd knobs. So as I scroll down a bit, you can get your pass or fail. You can get your red light, green light. And fine, I have some sense of how compliant I am. So wouldn't something be nice where we created a YAML-based syntax, a YAML-based language. Oh, well, I already, so for some control, like this one. It says I have to remove temporary accounts, and if I go in, this information system automatically removes accounts after some period of time. So I have to give some pros.
Is it the same control? It's AC2. What is that one?
Yep.
Okay.
So we use Active Directory.
On stage at Sydney.
On stage at Sydney. So I can go through, and in the US government, we have control identifiers. It's basically metadata. So it's our requirement key, if you will. So others might have ANSSI or PCI compliance or HIPAA, something like this. You can add as many control keys as you want. So we're just going to show the US Gov stuff for now. So if I save it, yeah, so let me rerun while I do this. So while I save it, we've gone through all the different control families. So for example, what you have to do for auditing, for config management, incident response, we've tried to break them into primary chapters that are widely applicable. And we went through and created, why don't we call it an answers file? So for everything here, we talk about how OpenStack, this is going to be shipping at OpenStack 13, so our next release from Red Hat. We talk about if it's not configured out of the box, what a user would have to do. So in this case, OpenStack can be configured for third-party authentication providers, but we don't know which one you're going to use when you install it. So you have to go through and say, oh, I'm going to use Active Directory, I'm going to use LDAP, whatever. So we give an answers file. And we went through and provided answers files for all requirements for US public sector cloud providers.
And these are on GitHub.
Mm-hmm. Yeah, it's on GitHub. And we're also, oh, the build worked. So we're also expanding that to have international standards, like we mentioned ANSSI. And
so Shawn, let me pause you here. So
Thanks.
You said the build worked. What is being built?
Not that I was surprised. So what we ended up doing is we recognized a couple things. So when I'm building my system security plans, you'll generally have like a Linux team, which may be separate than your networking team, which may be separate than your policy and process people. So wouldn't it be nice if we broke apart that 400-page Word document into chapters? And if I'm on the Linux team, I can go in and
Focus on config management.
Focus on config management for Linux. Or if I'm on the audit team, I can go in and edit the audit chapter. So now I can have multiple team members working on this documentation simultaneously. And behind the scenes, it's all based on Git. Or pick your favorite repository, but we use Git. So now the build system, it basically takes all of these chapters and makes a unified book out of it. Why don't we say it that way? Makes a unified, puts it all together. So now I can do a couple things. So in theory, I refresh. Okay, great. We update a web page. Who really cares about that?
Yeah. So just in context here, Shawn has a local Node.js server running here that's actually showcasing the web page. But I mean, he could have just went in and updated a web page. So that's not really that big a deal, right? So
Not at all.
What's really going on?
So what's also cool is now if we take a look, exports, you'll notice we now have the, I called it dash filled, if you will. Oh, it might help if I close my old edition out.
And yeah, the other ones as well.
So we have to wait, just a hot minute while it loads a 400-page Word document again. But what's nice is, what do we call it, Sydney?
Yep.
Cool. So now it replaces all of it. So what's the templating system is we're actually working with governments, US and foreign, so that we can translate all of the security paperwork into the formats that they expect. So for the US government, it's this thing. ANSSI has another, the Middle East has another, Australia has another. The point is, we can now provide authoritative guidance and then translate it to whatever formats behind the scenes that we need. What's also...
So you basically reduced 2,600 man hours to...
And that's not all.
a few minutes.
So what is...
So this, I mean, just to recap here, there was a massive blank FedRAMP SSP based on FedRAMP High.
Yes.
And the build system took that template and set it, I guess, or searched and replaced all the narrative content into that document to give you a brand new SSP that was relevant and fresh to what your configuration was.
Yeah, that's really good.
Okay, all right.
So
what else do you have?
What else do we have, Bob?
But wait, there's more.
Yeah, so part of that is, okay, great, we're updating web pages and Word documents, and yeah, that's really interesting, but I'm still a freaking operator, and I need some like Ansible and Chef, and I need some automation. So we've created this concept of profiles. So for the sake of this demo, we just made one for the US government cloud provider for low, like the super simple of the simple. And we selected a couple rules, just checking some file permissions, checking some use SSL, we're like super, super basic Horizon stuff, right? So now, behind the scenes, what's also going on is I mentioned we tagged that rule, like we actually named them, and I skipped over that. For example, Horizon use SSL. So we're just TLS enabling Horizon. Behind the scenes now, we have a couple other elements. So the first are configuration checks. So you can pick your favorite of Chef and Spec or Oval, which is the automation standard for the US Gov. And now if we have use SSL, the code is ugly. It's based on some weird XMLs. But essentially, it takes this file path, and it does this regex, returns true or false. So it's now machine code of, am I going to pass this configuration check? And we have a whole repository. So based on the rules selected in that profile, it says, OK, you want to do file permission checks. You want to turn on use SSL. Maybe you want to do some cookie encryption. You can kind of cherry pick these.
So you said inspect, Oval. What else? What other type of elements do you have there?
For check, it is just Chef and Oval today.
Okay.
So here's the associated Chef and Spec code.
Okay.
So now we've built a modular system where we don't care what automation you use on the back end. If you want to use Chef and Spec, totally fine. If you want to use the SCAP stuff, that's awesome. Just follow the naming convention, and it will actually dynamically build all of that for you. And then this is evaluation. This is red light, green light stuff. But we also want to do remediation. So out of the box, we have support for Ansible, Bash, Chef, and Puppet. So now you can choose your language, where if you want an Ansible playbook for OpenStack FedRAMP Low, it generates it behind the scenes. If you want it for Chef, Bash, Ansible, doesn't matter anymore. So let's actually see this maybe. So is that interesting? Is this kind of useful? Did you know we were doing it? Oh, I'm glad we came. So all of this is like GitHub nerdiness, and you can go into your favorite text editor and hack away, and a lot of people like that. But what's also nice is we wrote a workbench. So the OpenStack, why don't we just choose rel, because it's maybe the most, it has the broadest portfolio of configuration checks right now. And I can't really make the font bigger. But I mentioned we have a whole bunch of profiles. So PCI compliance, the US military, one for Docker, and so forth. One for the FBI or criminal justice people in the US. And why don't we just take one here that has a lot of rules. And I can actually click customize. So the OpenStack content had, what, half a dozen rules, something like this. The Linux content has hundreds and hundreds and hundreds and hundreds of things. It's just more mature. It's built out a little bit more. So now we can expose over checkboxes. Well, do I want password retry prompts permitted per session? Do I want to set minimum password strength? Do I want to disable SE Linux? So I can go through, and using checkboxes, I can choose what technical controls I want or don't want. And now I just hit OK.
Yes.
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 What was the?
Stop this. Yeah, exactly.
Have you guys seen this? Yeah. So somebody made that. Anyway, I guess it's a Red Hatter joke. So now the OpenStack content is just started. We're going to ship it out of OSP 13. So you'll find, it's more than half a dozen, but it's not hundreds at this point. And we've started by, Keith mentioned we wrote the OpenStack security book. We've taken all the recommendations from that and translated it into this automation format. That's done. That's on GitHub like right now.
So how does this relate to the build process?
How does this relate to the build process? Oh, so when wrong tab. Thanks for keeping me on track.
Yeah, this is not an Emacs user. I was going to fuss at him this morning about it, but I didn't. In the essence of time, I didn't want to get into an argument.
I don't even know how to use Emacs. Excuse me. So the idea is, behind the scenes, we convert all of this stuff to an XML standard. You don't necessarily have to know the code or know the tags. Just know that it's a whole bunch of XML. And you can see those rule identifiers that we talked about. So now we've transformed Ansible, Chef, Puppet, Inspect, SCAP, this OpenControl stuff into what's now been called a data stream. It's one big file that has all of that together. So here is a code snippet for an Ansible thing that, I'm not seeing the rule name. Oh, for making sure password completion is turned off, because some people don't want password saved and password completion. So here is a Ansible script. Right below that is the Chef Inspect script. So we wrote a data standard in partnership with the US Gov standards body, so we didn't just kind of make it up. And now we have one file that includes all of the automation. So you could do something like this. So I am running a OpenStack instance. 10 to 1129. Oh, come on. I promise I'm running an OpenStack instance.
You're pushing the edge, man. One too many.
See, it's running. Oh, I know what I did. Don't just turn off your firewall. Oh, come on. All right, well, good thing I have a backup. I am running a Red Hat Enterprise Linux instance as well. So on that Red Hat Enterprise Linux instance, I actually showed you the report. Blah, 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 I failed a whole bunch of stuff. So wouldn't it be nice if I could just run a single command that would change all of that red to green for me? Here goes nothing. Don't run it as root, you fool. And is this readable?
Yeah, yes, it is. I shouldn't be answering the question, actually.
SCAP security guides, that automation stuff I talked about. And I ran a build earlier. Let's use the Red Hat content, so I'm proving. And then also, I mentioned the NIST National Checklist Program. For those who haven't heard of it, it's a public thing. You can find it on the internet. And, oops, I clicked the wrong one. So the content I'm about to use it's live right now. It's not hacked up just for the demo. And the National Checklist, again, is that central repository of configuration baselines. Most governments are making their own. So as I go through, I choose the Red Hat Linux one. And this is just the Red Hat US government baseline for Red Hat Linux. So what we've ended up doing for that side of the pond is we took all of the standards and made a superset profile. So the military with the civilian, with the healthcare, with the PCI, and we just took the hardest settings and made a grand unified baseline. And that is now called the US government baseline. And what's also nice is they put my personal cell phone number. So if you have questions, just call me.
Just text him.
Just text me. which somebody did
Make sure
last
you're on
night.
Australian time when you do it.
Somebody did last night at 2 in the morning, local. Anyway, so I'm going to take that grand poobah, because while I'm pressing my luck, why not, really press it? So OpenSCAP is an interpreter. All that XML stuff is like HTML. And HTML needs an interpreter like Firefox or Chrome. So what we've ended up doing is creating one called OpenSCAP, open source interpreter of it. So OpenSCAP, XCDF, eval, I want to give it my profile, -- remediate, report var HTML Sydney, and sudo. The reason I have to run as root is because it's changing some stuff. -- remediate. Need to slow down. Had too many coffees. Sydney. I give it that rel7. We call it a data stream, -ds, that one big file. So by default, I'm doing a -- remediate. So by default, it just takes the bash remediations. And the reason we chose that is because we can be assured bash is everywhere. Every operating system, every version of Linux has bash. We may not know if you have Puppet, Chef, Ansible. So, oh, right. So this takes a minute or two to run. I just say, would it also, yeah, cool. So I have some passes out of the box. So I'm going to just kind of move that to the side. And believe it or not, part of the reason we just display it like this is because I didn't know how to write a progress bar in Python. Like, 1 out of 100 is 1% or something. I don't know how to do that. So I just dumped the array to the command prompt because patches are welcome. So while it does that, we'll see it kind of scroll by on the side. And it's a good time to show a secondary thing. So there are PCI compliance is pretty international. So we've done things where all of these independent configuration checks have metadata. So I showed earlier there were ones for NIST 853, which is like a US system. There are others for PCI compliance, HIPAA, DoD STIG. So we can take the identifier of the requirements. So PCI section 818, you have to turn screensaver, set a timeout, actually enable the timeout, define the time period, and so forth. So now we also generate paperwork that is specific to the compliance profile you have to adhere against and specific to the component that's being evaluated. So a PCI compliance table for Linux, a PCI compliance table for OpenStack, for the middleware, all of that is dynamically generated for you. And what's also really cool, oh, it's still running my little configuration scan here. What's also really interesting is we have variables when you type them correctly. Yeah, so setting minimum digit characters, minimum length is generally it's a variable. So when you update the variable, it'll update that Microsoft Word document translation thing. Mm-hmm. It'll update your bash, Ansible, Chef and Spec, Oval, Ansible, Puppet. It'll update all of that just by changing one variable. My laptop's like, I guess you can't hear it from the audience, but the fans are going. So because it's boring to wait for a command line thing, we pre-populated the pre-hardening report. And then we also did one yesterday, just in case it took too long, of post-hardening. And you'll notice a lot more green. And I'll show it once it passes. But the idea is there are some things we do not want to remediate. An example would be we're not going to, like the US government still wants like /home to be on its own partition. Whatever we may feel about it, we're not going to just arbitrarily make a /home as a physical partition on your machine. We're not going to touch disk formatting. There's also some other things like apply security patches. We're not just going to randomly run a yum update. So you'll still see a couple things that are not going to be remediated, but that's very purposeful. So how's that? Is this interesting for you? Oh.
So your firewall just turned back on, by the way.
Yeah, it did.
So
there's a couple things here. You'll also notice errors. Those are bugs. I don't know why it's erroring. Straight up, just tell you that.
So
that sucks.
to recap, it's a tool. We've got a set of tools here.
Yeah.
We've got a common definition language based in JSON that we can put in Git and manage like we do any other software development process, right? So that gets into the repository, and then we can run this tooling to gather all that up and to create the artifacts that we need, so to keep us up with the speed and the agility that we need. So that's the summary here, and Shawn is showing, some of the output of the tool set. Do you want to take questions while this is running?
Yeah. So does this make sense? How would we make it more useful for you guys?
Yes.
I just want to ask you, just to make sure, the original artifact you're talking about where the different auditors would be inventory, who was responsible for the split and that thing. And then you showed on the command line that you're outputting to an HTML. Is that HTML that original guide?
It's not. It's the HTML is it's kind of like the report. It's in the gap analysis.
Yes.
We also output a PDF. Can you show the PDF?
Yeah.
And the Word document. So the big Word document is the thing that you would submit in the FedRAMP case to the JAB so they can review what you're doing on the system. But so you've got the Word document, you've got a PDF version, and you've got the HTML in terms of report for the gap analysis.
Yeah, and the reason for that is a lot of people hook all of this up into Git. So Keith showed the Trello / Kanban board / Agile thing where you'll have some action that says PKI enable Horizon endpoints, TLS enable them. So you'll generally have some pull request that changes a configuration to TLS enable your endpoints. As part of that, you'll have some configuration change. You'll have maybe some paperwork change. You'll have maybe some Ansible playbook. And the idea now is when that change gets merged, a lot of people want to have just a rolling active web page of what the configuration settings are.
Yeah.
So now you can build this into your CI/CD system, so your paperwork, is automatically exposed.
Yeah, and in terms of your whatever development process you have, you may need to go in and modify your definition of done, for example. So in our case, delivering the compliance work related to this will be our new add-on for the definition of done.
I forgot when we're supposed to be kicked off stage right now.
I think we've got 5 minutes. Yes, sir.
So, Basil, you talked about some BUGZILLA stuff,
Yes.
configuration stuff. You said we. Is Red Hat we? And if so, is that available to other people to use? Is that something that we expose?
The community is small right now, so and it's growing though. I don't.
Just Red Hat?
No. There's others like Pivotal, Amazon via 18F, et cetera. But the JSON formatting has not fully jailed in terms of a standard yet. Like Shawn and I, for this demo, there were some things we introduced, like the narrative work. So it's getting there. It's really close, but there is some specificity toward our downstream implementation.
Forgot what I was doing. A couple things while we, to finish out. We focused on OpenStack and Linux for this demo. But we also want to recognize there are CTO office controls. When I hire somebody, they have to go through a privileged administrator, don't delete the system, or kind of, like privacy briefing or something like that. And that's done at your CTO office policy level. And then oftentimes you have program office people. This is the program office methodology for app 1.0 or for division A or B. So what we've ended up doing is, the internet's a little slow. What we ended up doing is writing the build system so that I mentioned it's kind of chaptered. So pound include kind of functions, if you will. So now I can actually inherit all of the organizational controls I commented the program controls out because just for time for a demo. And then I can also inherit all of like OpenShift or OpenStack, and I can do a diff. So that means give me every layer of my infrastructure from org people policy to Linux to OpenStack to my middleware server, and tell me all of the controls that I haven't addressed for the entire infrastructure.
Yep.
For all of the components.
Yes, sir.
What was the role of OpenControl in your demo?
Yeah, OpenControl is it is the name of the YAML-based language. It's a schema. It's a schema. It's YAML, so it's not really a language per se. Well, I don't know. We can debate that, but it's a schema.
And is this driving the generation of the XML data file that you were showing?
Yes, it is. Yeah, so we do it a couple different ways. So the first are, the first edition we did for the US government because they just partnered with us first. So now we tagged it with control keys. So, why don't we just say requirement 1, requirement 5,
Yep.
and so forth. When we go into a product like Linux or OpenStack, we have individual configuration checks like Horizon use SSL or 5-character passwords in the OS. So for every configuration check, we map the metadata of the control keys. So when we run it through the tooling, we can do things like give me all of the configuration checks for Linux and OpenStack tied to DoD, tied to HIPAA, tied to whatever standard, whatever profile you choose.
And then the last question is the scan bench that you were showing, is that an alternate way to be able to toggle the controls that you want to check for?
So the alternate way, so SCAP Workbench, why don't we call it a tailoring tool, not a authoring tool? So I can go in and I can choose a profile, I can expose it as checkboxes, I click what I want, I uncheck, change some variables, but you're not necessarily authoring content. So how this works, for example, in the US military is the big CTO office will say this is the US military baseline for a thing. And then they can use the tailoring tool to say, look, I know this is the corporate standard, but we deviate here, here, and here, and here's the justification. So the program people would tailor it, whereas the CTO people might author it.
And then the output of this would be that XML template as well at the end.
Yes. So either way, if you use, that's a really good question. So if you use the Workbench thing, it ships on Windows, Linux, or Mac. If you're running it on Linux, you can do a save as RPM. On a Mac, you can't. There's no like RPM build tools. Or you can just save it as that XML file. So either way. What's also nice is underneath the covers, it means we can authoritatively publish like that US government baseline from NIST. We can say that we started there, and then it will document what you enabled or disabled, your drift, and then you can cryptographically sign it. So now we know authoritatively you started with the US government baseline, you turned a couple things off, you re-signed it. So as you distribute that body of automation to your endpoints, you can say authoritatively, like, this is the baseline our CTO people approved.
Cool.
Kind of interesting.
One additional question.
Sure.
So Keith, earlier on you were showing how to conduct it, right? Like in
Yep.
from a FedRAMP perspective, you have the low, high, and the medium level.
Yeah, low, moderate, and high.
Right. So is there a certain set of parameters in, say, the directory templates to be able to enable a certain set of
That's a great question. So we're getting there, and this tooling that you're seeing is bleeding edge. It's very new. There is a point where we're going to have a serious conversation with the director team on how to embrace this. So today we're doing post-config hooks via Ansible playbooks to actually do individual, remediations. But this is a much greater tool than that. So we're thinking that in the future we're going to build out work here and then use a post-configuration hook to call this to remediate the system so that it's all clean. That way we have one authoritative source where all of remediations will happen. So that will be the integration point in the future.
As part of that, we predefined like FedRAMP low, FedRAMP moderate, So it's just a list of mappings. So when we run the build system, it's called compliance masonry if anybody's heard of it. But when we run make, it'll basically say, make -- profile FedRAMP low.
Yeah.
Here are all the metadata tags.
This is important because it gives us leverage. Like, we can't expect our internal security engineering team to know all of this as they work on features. It would be much faster and more efficient for us to point to this and have all the work from that be incorporated into the deployment as a check.
And then as a closing point, the OpenStack stuff is new, right? That's OSP 13 for us. If you're using Red Hat 6 or 7 or CentOS or Scientific of those versions, we already integrated this into the Linux installer. So when you click, and you just skip over it, one of the screens you skip over says security, and it has a drop-down menu of all these profiles out of the box in Linux. So we're going to start expanding that to OpenStack, OpenShift, which is our Kubernetes container platform, and our middleware.
Yep.
Kind of cool.
Yes. Thank you.
Was that silent cheers? No, it's not very cool? Oh, fine. No claps.
It's okay. It's okay, Shawn.
I'm going to go back to America crying. So, all right, thanks, guys.
Yep. Thank you very much.
Yeah.